Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem, next module, problem number 10, fluid mechanics. As usual, first we come towards its statement. Okay? State your mass and then estimate your volume. Hint is given that because you can swim on or just under the surface of water in a swimming pool, you have a pretty good idea of your density. Okay. Dear students, here we have to state our mass. That is, every person has its own weight, its own mass. Usually, weight of a normal human being varies in between 70 and 80 kilogram. Okay, so we will assume um, mass of a normal human being, and then we will find out volume. Okay, here hint is given that because you can swim on or just under the surface of the water in a swimming pool, you have a pretty good idea of your density. It means a hint is given that we have to take density as density of water. Okay, and density of water is given in the table of densities. Anyhow, now we come towards solution. Okay, solution. Let us assume that mass of a normal human being is 75 kg. Okay, as I have previously told that mass of a normal human being is about in between 70 and 80 kg. So we assume it to be 75 kg. Okay, let us assume that mass of a normal human being is 75 kilogram. Density is mass per unit volume. Okay, what is this? This is the definition of density. If a mass m of homogeneous material has volume V, then its density rho is given by rho is equal to m over V. This is equation number 1. What is this? This is just definition of density. Okay, rho equal to mass over volume, m over V. Okay, we know from table of densities that density as per hint of water is 1000 kilogram per meter cube. Okay, in the table of densities, densities of many things are given, all things are given. Okay, but because in the hint given in this problem, we are asked to consider the density of water as our density. Okay, so in accordance with the hint given in the problem statement, We know from table of densities that density of water is 1000 kilogram per meter cube. Rearranging equation number 1 as volume equal to mass over rho, mass over density, we get V equal to m over rho equal to mass is because 75 kg and rho is equal to 1000 kilogram per meter cube. Okay, what we have done, this is equation number 1 and we have rearranged this equation from here. When volume will be shifted on other side of equality, then it will become in the numerator and density will become in the denominator. Okay, volume will become equal to mass over rho. Volume has become equal to mass over rho. Mass is not given in this statement, in the problem. We have assumed that our mass is 75 kg. Okay. However, rho is also not given in this statement. Only a hint is given that we should adopt density of water. Okay. So it is almost given in the statement. So we have put both these values. From here, kilogram will be cancelled out with kilogram and meter cube will become in the numerator, and after simplification volume will become equal to 0.075 meter cube. Okay, it is not appropriate to write it as 0.075. Okay, it is appropriate to read it as 0.075. Okay, after decimal each digit should be separately pronounced, separately read. Okay, this alternatively becomes equal to 0.075 into 1000 liter. Okay, and when 1000 will be multiplied with 0.075, then it will become 75 liter. Dear students, actually 1 cubic meter is equal to 1000 liter. This is given in the table of conversion factor, and in the later part of this module we will discuss this table. Okay, what we have done, in place of 1 meter cube we have used the value 1000 liter. Okay, 1000 liter is equal to 1 meter cube, or in other words 1 meter cube is equal to 1000 liter, and in this way 0.075 becomes equal to 75. Okay, so volume has become equal to 75 liter. Now we will move towards the table. Okay, this is the table of densities. Okay, from where we have taken the density of water. This density of water at left column and at serial number 5, water 1.00 into 10 raised to the power 3 kilogram per meter cube. Okay, that is 1000 kilogram per meter cube. This is only to the extent of density. Now in the next conversion factor table, we are going to disclose this fact that this is liter. 1000 liter is equal to 1 cubic meter. Okay, liter, 1000. 1 cubic meter. 1 cubic meter is equal to 1000 liter. And alternatively, 1 liter is equal to 1.00 into 10 raised to the power minus 3 meter cube. Okay. So but there should be no doubt why we have chosen 1000 liter equal to 1 cubic meter. Okay. It is quite clear from this table. Okay. And this is the end of our problem. We have solved our problem. So volume of a normal human being whose mass was 75 kg has become equal to 75 liter. From here what we can conclude? We can conclude that a man whose mass is 51 kg will have a volume of 51 liter. A man who has mass of 82 kg will have a volume of 82 liter, and so on. Okay. So this is the end of our module. However, at the end we will give reference. Okay. Dear students, reference book is Physics for Scientists and Engineers with Modern Physics. Its author is Douglas C. Gyankoli. Its publisher is Pearson. And its fourth edition, which was published in the year 2009, has been adopted or followed while solving this problem. And chapter number 13 under title Fluids of this book is our concerned chapter. And this problem is enumerated at serial number 4 of the exercise of this chapter, that is exercise number 13.4. And this is the end of our module. Okay.